Ken Hollinger, and this is going to be a product teardown of the, I don't know how you say that, Roman numeral 8 700 rival Nerf gun, aka the Helios. It has a 7-round magazine and fires at a rate of 30 meters per second. We're going to do a teardown, and specifically we're going to look at functions, materials, and methods. So for each piece, we want to look at it and we want to contemplate what is its role in the system, what material is it made of, and what was the manufacturing method. And we won't know everything, but we'll talk about it, at least make an educated guess. A little bit more about the Helios. The blaster has a spring action mechanism and includes an easy loading 7-round magazine and 7 high impact rounds. This Nerf rival blaster also has a trigger lock to prevent the blaster from being fired accidentally, a ready indicator to show when the blaster is primed, and a tactical rail to customize with Nerf rival gear and accessories, each sold separately. The bolt is removable so battlers can place it on either side of the blaster to customize for right-handed or left-handed battlers. Fires rounds at a velocity of 100 feet per second or 30 meters per second. Comes with an easy load 7-round magazine and 7 high impact rounds, ages 14 and up.
So what do you know?
What I know about this, I've played with it in the office a bit. It's a pretty good gun. It fires very fast. Sometimes the bullets or the Nerf rounds will curve wildly, so it's not exactly reliable. Also, it seems to jam at inopportune moments. It says that there's a flagging mechanism that lets you know when the round is loaded. I haven't figured out what that is. I don't see it, but as a demonstration of how it works, here's the magazine. These rounds feed in the top, and as each one pops out, this works like a standard magazine. This is the safety on either side. If you cock it and try to fire, won't fire. Take the safety off. This is the decocking. Sometimes it'll become jammed, and when it becomes jammed, you can use this to try to undo the jam. There's this window right here that I'm not sure what its purpose is, but I know if you slide it like this, you can watch the ball feed into the chamber, but if you leave it open and you try to load around, it will jam. Didn't jam that time, but it jams a lot. And then when it does jam, you kind of got to play with it and then keep decocking it, and you can usually unjam it. This is the rail for attachments, and that's everything I know about the weapon.
What do you think you'll learn?
I'll learn how it works. I hope to be able to understand it well enough that I could do a function flow diagram or energy diagram, that I'll be able to do a searching for the words. Oh, one thing I forgot to mention, this the bolt that they talked about that comes out, you push this here, comes out, and then it goes on the other side. Alright, we're going to start the teardown with the magazine, or actually the rounds. Each one of these rounds is about 3/4 of an inch in diameter, and it's made of a spongy, kind of sponge material. I think it looks like, because it has a line around the thing, it looks like it's made in a mold, and then the mold pops off and it comes out. So this is the magazine. I'm going to attempt to take it apart, see what's inside. Even though you can already see inside that there's a spring. I guess we can talk about the components a little bit before I take them apart, but everything in here looks like it's made of hard polymer plastic, injection mold. This part down here is a lot softer rubber, and then it's made from metal screws. And we'll take apart each component and talk about it individually. So there's 2 screws in the top, and I'm just gonna use this screwdriver to try to take them out. So this is the top. It looks like it's meant to keep all the other parts in place and to keep this piece right here, which the spring pushes the ball up, and then it's got this lip here that's just smaller than the diameter of the ball. So we've broken this down into, it looks like there's 3 pieces on here. I was able to get the spring out of there. It just kind of sits in there. And the spring, its purpose is to keep this little lip pushed in, and that kind of retains the Nerf balls. And manufacturing method, or its material, it's made out of metal, and its manufacturing method, I guess, is extrusion, and then it's bent into a coil. This one's a bit of a puzzle. So I'm just wiggling this to see if there's some secret way that it fits in there. They got it in there somehow, so presumably it can come back out. It feels like maybe it snaps in there, and it's not meant to come out once it gets snapped into there. I don't want to break it, but I can see all the pieces, so I'm not sure what I would accomplish by taking it apart. Another spring, this one's really flimsy. Looks like when it's compressed down, it's to an inch, but it extends out all the way to 14 inches. So it's obviously to feed the balls in, and it's made out of metal, and it's probably manufactured by extruding the metal and then coiling it. Last piece of the magazine is this rubber bumper on the bottom. I think the purpose of the rubber bumper is to protect the hard plastic from shattering. The look of it, it's not snapped in place. It's actually, my guess is that it's glued on. So since I don't want to break this and I can see all the parts, I'm just going to leave that on there. That's the magazine, and we're going to go ahead and take everything out of the magazine out of the way so we can concentrate on the weapon now. Alright, here we have the main assembly of the weapon. Looks like it's about 16.5 inches long from top to bottom. It's about 9 inches. The first piece we're going to take off is the cocking lever, which is usually, you pull this, you reach in here and you pull this back and it pops right out. This is made of molded polymer plastic. And it's got a line here that I would think is from the molding process, but it's got a screw inside. So we're going to take it apart and see how it comes apart. There's a small screw inside of here, and this top piece comes off. I'm not sure why they made this into 2 pieces. It seems like they could have just molded it into 1 piece. Maybe because they couldn't make both sides rounded and they wanted to keep the walls inside. I think that's actually it. They made this into 2 pieces so that it could be round all the way around and have constant surface, have the inside still be hollow. So that's my guess as to why they did that. I know if you try to make the plastic too thick, that in the drying process it can cause warping or cracking or structural flaws. So it's probably for those reasons that they broke it down into 2 pieces.
How do you know that?
From a homework assignment that I did that talked about manufacturing recommendations for molding polymer plastics. Next, we have the main assembly of the weapon, and I'm going to start with, there's a bunch of screw holes, and I'm just going to start getting all those screws out and see what happens. So this is coming off mostly, but it's attached to here, and I think it's snapped in, and it doesn't feel like it wants to come out without breaking, so I'm just going to leave it alone and keep unscrewing more screws. But it looks like, to me, they could have made it 1 piece, but to use different colors in the mold, that they broke it down into more pieces. And that's why, for instance, you have this piece separate from this piece. It's just because this is white and this is black. I'm just going to keep unscrewing screws, and hopefully they'll just come apart nicely without me breaking anything. without going. I don't know why it keeps making that noise. That seems to indicate that it's all the way unscrewed, so I'm wondering if these screws are the kind of screws that don't screw out all the way. Oh, no, we've come out with a screw. And these are the same size as the screws from the... I take that back. The screws for the magazine are slightly smaller than the other screws, but other than that, they look almost identical. Identical material, identical manufacturing process. It's just one's a bigger version of the other. And I think that ticking sound is just what happens when I've unscrewed it all the way. So that's going to be my indication that I don't need to unscrew anymore. I hear that. Anyways, each one of these screws looks about 3/8 of an inch long. Where did that big screw come from? One of these screws is bigger than the other, and I don't know which hole it came from. So hopefully we'll be able to figure that out before we put it back together. First mistake of the day. I'm wondering when the Russians found the B, I think it was the B-29 Fortress, and they took it apart piece by piece. I wonder if they made any mistakes like that, and how much it cost them and lost time sorting that out. So if there's a big screw, I'm going to go ahead and mark the location with a big X. Another big screw. So I'm thinking maybe all the small screws were these ones, and then maybe these are all going to be big screws. So far, that's been a big screw. That's been a big screw. I don't have that one out, and I think that's a big screw as well. I think all these down here are small screws. Another big one. There are, looks like 2 screws left that are visible. That's going to be fun to put back together. Not. Alright, I don't know how to show you this exactly. Trying to keep the pieces together. But this is what the inside of the gun looks like. And I would perform a vivisection, but I'm afraid to move anything and it'll just come apart.
Go.
Hi, we readjusted the camera angle so that we could get a better view of what's going on. Can you see me? So we could get a better view of what's going on from the top, so you guys can get a better idea of what I'm trying to do. So right now we're trying to figure out what this piece does, and it looks like this piece right here, when it cocks back, goes here, and it's got this lip right here that will catch on this piece. As you can see, if this piece slides up. So what I think happens is it comes back and it will cock right there, slide into there, and then get caught on here, and then I think that's the hammer, because when the trigger, which is attached to this metal rod right here, hits, know if it works right now. It doesn't work very good when it's taken apart, but I think what happens is when you pull the trigger, that it causes this to pull this piece here moves up, and then it pushes on this piece, which allows this piece to slide forward and shoot the ammunition. And this piece is made of the same plastic, hard plastic, as the rest of the weapon. It feels a little bit oily. I think they put some oil on it because of friction, and it consists of 3 pieces. And right now I'm trying to figure out if I'm going to take it apart more or if I need to. If I can do it easily, I'll do it, but it doesn't look like I need to, so, or it doesn't look like it'll come apart easily, so I think I'm just going to leave it the way it is. But it's pretty self-explanatory. You can see all the pieces in there. You've got this piece that slides up and down, and you've got the spring that pushes it down. I think I'm going to just leave this together, but we can see all the pieces. It would just be, there wouldn't be really a good purpose to taking it apart other than to prove that I could. So this piece right here, you know, now that I'm feeling these pieces, I actually think that there's a slight discoloration between this plastic and this plastic. And I'm wondering if this plastic is in a little bit different material to adjust for the friction. But this piece right here definitely feels oiled, and I think it's just that, maybe the oil, but it does kind of look like it has it's fuzzy around the edges, so a slightly different manufacturing process than this hard plastic here. So I'm going to go out on a limb and say this is made of a slightly different material than the rest of the polymers, and it's built to be an internal component that is maybe a little bit more malleable because of the friction involved. So this is the trigger right here, and like I said before, when you pull the trigger back, it pulls this thing forward, and then because this is leveraged a lot, it's like a lever, and so just for that little bit of trigger pull, it moves this big ramp up significantly. So the purpose of this piece of metal, which is made with the extrusion and then bending, is to be the linkage between the trigger and the, we'll call this the trigger lever. Oh, looks like that wants to come out, so. Alright, so here's what I think. This is the piece that the cocking lever pulls back. And as you can see, it's kind of pulling back there. And I think this piece is like really strong. It's like a very strong spring inside of here. Spring or whatever is in here that is the actual charging system for the weapon, that it's actually really hard to pull this. So what the cocking lever does is it slides this gear across so that it's effectively like a pulley system, and that you get twice the force. You have to pull twice as far, but it reduces the force that you have to cock the weapon. So that's the purpose of this piece right here, is to interact with this cocking lever that pulls back here, and then to kind of multiply that force, or actually descale that force across here. So you have to pull twice as far but only half as hard to cock this piece back. So that's the purpose of this. It's a gearing system to reduce the force that's necessary to cock the weapon. And not sure how this metal piece keeps that in here, but I don't want to break it, and maybe we'll save that for later. So this right here, I established, like I said, this is the charging system, and it pulls all the way to the back and then locks back, and then when it gets triggered, it lets go and releases the force there. And so this is I talked about the cock release, and when you wiggle this, it can, I guess if it's pulled back all the way and it's locked, then wiggling that will somehow get it to be unlocked.
Why do you think that?
Well, this is the locking lever, and sometimes it gets jammed, and I think it gets jammed when it's almost all the way home. When the ball misfeeds into there, and this thing's locked, and it's and then you can see as you wiggle this, it kind of wiggles this a little bit. So I'm going to go ahead and take this piece out. Interesting. So let's focus on this piece right here first. This piece right here that goes forward feeds directly to where the ball sits right here. And when this springs forward, it's got this rubber assembly here, and it pushes all the air that's in here through these holes. Now what I can't figure out is what the function of this screen is right here. I'm guessing, my guess is if I did a vivisection and I took this piece out, that the weapon would still work without this. So that would be an interesting experiment to conduct, to just completely take this piece out of here and see if the weapon still works. Because right now it's not apparent to me that it has any function. I think when the ball feeds in there, that this, that this tube pulls forward, and the ball comes up to the bottom, and then when it slides back, it rests up against this surface right here before it gets launched. We'll look at this piece. This is the very strong spring I was talking about earlier. This is the main charging spring for the weapon, and it's very powerful. And it's made out of metal, and it was made using extrusion and then coiled into a spring. Where we're at right now, we have this piece feeds in here. The plunger pushes the air, which pushes the ball out of this barrel right here. This is the spring that provides the force that pushes the air through the ball. This is the counter, or I don't know what the right word to say is, but it provides a place for the spring. Right, and this is the cocking. This is what nub allows it to be cocked, and this is the piece that allows you to wiggle this when it becomes jammed. All made out of very hard plastic, and the surfaces are oily. It's been oiled, and that's that assembly right here. Let's see what we have left. This is the cocking piece right there. Oh, that's neat. So what I just discovered is that, I forgot this, is when you start to load it back, it ratchets back. So I think this right here is, we're gonna figure out how it ratchets it back and what mechanism it uses to make it so that if you charge it part way, it doesn't just automatically go forward. You can pull it a little bit back at a time, and each time you pull it back, it'll stay where it was until you get it all the way back, and then it lets it go forward. So I am doing a little bit of vivisection here. We see each time it starts to go back, 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 and then as it gets near the end, this barrel comes forward. That's when the ball feeds into the barrel. And then also, once it's ratcheted back all the way, there's a little pin in here that you can't see, but I can, that allows it to go ahead and go all the way forward, which pushes this lever, which takes the barrel and pushes it back into the ball. There's a little rubber plunger around here that keeps an airtight connection between the barrel once it slides into this piece to keep an airtight seal. I kind of want to take a moment and just contemplate this, because I think we've seen all of the major pieces working together, and I kind of have an idea how it works, and right now I kind of want to think about that for a second and see if there's any obvious things that I would change. It's not obvious to me that it's a flawed design. I know it's not perfect because it doesn't work all the time, but it's not immediately apparent to me how I would make it any better. But yeah, it's actually pretty complicated the way all of these pieces work together. We have this part moving, this piece levers this piece, which moves the barrel forward to lock the ball in place. You've got this window here, which I think lets you see the ball if you have like a misfeed, so you can get in there with a screwdriver. I think that's the purpose of it. I don't think you're supposed to try to load the ball with it open, and that's why that causes the failure when you do that. It's a pretty neat design. All right, let's keep taking it apart and see what else we can sort out.
What's the problem?
Oh, they're just kind of all hooked together. I think what I'm going to do is I've still got, I haven't taken apart this piece yet. I'm not sure actually how it comes apart. Oh, there's a spring that came out. All right, since that came off, we'll talk about this piece next. This piece was inside here, and it's connected to this button with this spring. Now that the spring's gone, the button doesn't wiggle anymore. And this is the magazine release. So it's a combination catch that when you push the magazine, it keeps the magazine in. And then this button is the magazine release. And so this is made of the same plastic, the softer plastic, not the hard plastic, as the other soft plastic pieces, and then another spring. So far, clearly there are two different types of plastic. They're the kind of, they have a softer feel to them, and you can see when you look at them that they aren't quite as shiny, and they feel a little bit softer, and those seem to be used for all the internal pieces. And then there's the harder plastic. So I'll just start calling it by the hard plastic and the soft plastic, and and I feel like I'm not taking it apart the right way anymore. And that's assuming that there is a right way to take it apart. But I think that's a pretty safe assumption, because people assemble these in a certain order, and I think that I am no longer going in the reverse order of assembly, which is usually if you're disassembling it, you would want to attempt to disassemble it or assemble it. The assembly and the disassembly you would assume would go in the exact opposite order. This one, the screw's a little bit different. It was in the top here, and it looks like it's on there to hold the piece that slides back. This is the piece that lets you unlock the cocking lever that slides into there. So
What did you just pull out?
so this piece right here, which I don't know what to call these things, but we'll call this the cocker. It's what cocks the gun. It's the main interface. This piece right here goes on top, and it's got a spring that locks it forward. And if you pull it back, it lets you pull this out and then put it on the other side. Oh, good. Yay. So I took this piece off. This is basically the twin of the other side. To me, it doesn't look any different at all than its sibling. It almost looks like an exact copy, just done in the other side. So I'm gonna go ahead and not take apart this because it's the same as this. Comparing them together, they look completely the same. The only difference, I think, is the fact that this one has the screw holes that go in, and then this has the receiving places where the screws get received. Did I say that right? Okay, now we're left with...
What is the black part of that?
This?
Yes.
Again, like before, it's just... It's cosmetic. They use two different plastics so that they could get this nice black piece all the way through, and then have that nice contrast. So I think this could all be one piece. And it's again, it's just snapped into place. All right, now. So up here, this is pretty neat. You see this spring right here, and what it does is it holds the lever right there. So when it starts going back, it keeps it locked in place, which it doesn't now because I'm missing pieces, but so you see it won't go forward until you push it all the way back, and then it goes ahead and it lets you ride it forward. But this spring right here is what keeps that piece. It's what holds the ratcheting piece so that it ratchets. And then once the piece goes all the way back, actually, I don't know if you can see that right there. It's that piece, it holds up, and then it's spring loaded to kind of, right now it rides on these teeth, which allows it to not go forward. But then, once you get past a certain point, the spring keeps it back, and then you can slide it all the way forward. Oh, cool. This piece right here is a piece that when you're sliding this back, this is the cocking lever. It lets it slide all the way back, and then it doesn't pull it until it reaches here, and then it pulls it. So that's what allows it to not pull this piece until the very end. So that's the purpose of this piece right here, is to delay the cocking until it's the finishing stage of the pulling it back. Or this is the little nub that as you pull it back across these, you can see the spring is what keeps it from just flapping up top. So that's what keeps that ratcheting action going. Pretty ingenious. So this is made out of the harder plastic, and these two pieces are made out of the softer plastic. And this is the button that releases this catch. This is made out of the harder plastic. and it is the button that pushed the spring that would cause this latch to release the magazine. There's a screw here, and it screws the spring in, and the spring is what keeps the copper pushed forward. Go ahead and take this piece. This piece is hard plastic. It's purely cosmetic. Well, maybe not purely cosmetic. It has these air holes here for air, so presumably the air can flow into the gun, and then it's to also keep other pieces out of this area, so it kind of just blocks that area from stuff coming in here. I'll take this piece off. We talked about this piece earlier. This is made out of the softer plastic. It's kind of what gives that leveraging action that we discussed earlier. Here we have the barrel, and you can see it's got this rubber seal around it that keeps the air from flowing around the sides when the air from the plunger releases into, pushes, so the ball basically rests right there once it's loaded and waits for the spring to push all the air through here. This feeds right there. And then the projectile comes out this end. This piece right here is metal, and it looks like it was made using extrusion. It's just a little sip of metal, and its purpose is to allow the barrel to be opened for the ball to be fed here, and then again closed to wait for the projectile to be ejected. It looks like the ball is just big enough so it's very slightly wider diameter than here, just enough so that the ball doesn't go anywhere once it's fed into the chamber. You can see that it is, and I can feel oil in there, but it's the chamber is slightly less in diameter until about the halfway mark. And it's got like a little ridge there, and I'm guessing that ridge is to affect the the trajectory of the ball. It's even got like a little piece right there that I'm not sure what the purpose of that, but that piece right there coincides with this little blocker right there. So I'm guessing that they, when it came to figuring out the fine tuning, just like a rifle has grooves in the barrel to affect the trajectory of the bullet, engineering this piece of tube, probably they spent a lot of time figuring out how to engineer it just right. I think that having the tube slightly smaller here keeps the ball in place. Once it's forced out, it reaches about the halfway point, and then it gets released. And I'm just gonna go on a limb here, but I think that this piece right here was engineered, they probably played with this a lot, and that's why it's its own separate piece that feeds into there, to get just the right amount of to hit the ball and cause it to spin, and maybe that way it would have a predictable trajectory once the arrow exits the barrel. So I think the ball comes here, it hits this, and then it causes it to spin out, and then it's got this little groove right here on the bottom, and that goes all the way down, and I think they played with that probably a lot when they were designing it to try to get at least a predictable trajectory, so that it does the same thing every time as it exits the barrel. Otherwise, if you had spinning it left or right, it's going to curve because of you might have just like in sports, you would have laminar flow on one side, turbulent flow on the other side. The laminar flow is going to feed off here and then cause the bullet to swerve one way or the other. Now, the question you might ask is, why doesn't the ball, actually I'm asking myself right now. So this is on the bottom, which means that the ball is going to hit it and it's going to start spinning that way. If it's spinning, if it's got a top spin, then the laminar flow is going to come up from the bottom, and you would think that the projectile would curve downward if it had turbulent flow on one side and laminar flow on the other side. But that's all just speculation without more experimentation. I'm skeptical of what I just said myself. All right, next piece. All right, making some headway here. All right, so this is the safety mechanism, and it goes right here to, it links when you put the two pieces together. So this random spring fell out. I don't know where it came from, but it's a spring, and it was in there, and now it's not. Like I was saying earlier, this safety right here matches with its twin over here when the weapon's put together, and I know when it's down, the safety is engaged and it doesn't work when you pull the trigger. And take a closer look at the trigger. I believe the spring was to keep the trigger forward. We just lost, and in fact there it is. So the spring went from here to there, and it basically just keeps the trigger forward. And right now, if I pull the trigger, nothing happens, and that's because the safety is engaged. But once I take this side right here and push the safety up, then I can go ahead and pull the trigger. At least that's the theory.
What are you thinking?
I'm thinking this is a pain in the ass. I'm not sure what's blocking.
Why did you say oh?
Oh, because I thought I had it figured out, but I didn't. So it appears that this piece right here is the piece that's blocking me from pulling the trigger. So I think this piece right here is somehow, that's interesting. So, okay, I did figure something else. I was wondering what the purpose of this piece is right here, and basically it's just it gives you a little feel, right? It separates, so this is, it's on safe, this is off safe. And when it's off safe, this little piece right here would tend to it gives you a tactile feel to let you know. And then I think it also prevents it from just moving on its own. So that's the purpose of this whole assembly right here, is to provide that tactile feel as I go back and forth. Interesting.
What are you thinking?
Well, I was just playing with this, but I happened to look at that, and we'll talk about that in a minute, but I wasn't expecting to see that right there. I think I just figured out why the weapon jams when this window's open, and basically because when the window's open, it doesn't have that piece right here. But now I'm still trying to sort out what the deal is with the trigger. I'm going to kind of put it back together with some missing pieces to kind of play with it for a second. You can see I'm pushing the other side, and it's going up and down.
Why do you think putting it back together will help you figure out the problem?
Because this piece right here is what's blocking me from pulling the trigger. So this is somehow connected to the safety. But when I don't have this piece on there, maneuvering the safety doesn't do anything to that piece. So what I was hoping is that when I put it back together, it would become apparent to me how that piece gets affected. Oh, okay. I think I figured it out. There's actually two safeties. So let's play with that for a second. Let's put the trigger back. There's actually two things that prevent you from pulling the trigger. One is this piece right here. which, oh yeah, so when the barrel comes forward, right, it would be disaster if the, actually it's right here, this piece right here. So in the book that I was reading, you're supposed to take everything apart and look at all of it. And I ignored that. I didn't look at this piece right here and I didn't contemplate what it means. So that's a good lesson learned. You have to kind of look at everything. I mean, there's stuff in here that doesn't really have a purpose. It's just for structural integrity. But this is obviously not for structural integrity. This piece right here has a purpose. And the purpose is to prevent you from pulling the trigger while this barrel is forward. So when the barrel goes back, then you can pull the trigger. Everything's hard plastic, but all of these pieces inside, this piece, this piece, this piece, are all soft plastic. And we're almost done. There's just one thing, last thing I want to cover. So this piece right here, when the weapon was put together, I didn't really understand what it was for. And it looked to me like it was just something that you could slide forward and then you could watch the ball go into the chamber. But every time you did that, it would double feed, the weapon would become jammed, you'd have to use the decocking lever that we went over to play with it until finally the ball would fall out and you'd have to take out the magazine, everything to get it unjammed. And so I thought, well, that's kind of dumb. Why would they have this in here to have, so you could look at it if it doesn't work when you look at it. So then I came to my next thing and I said, oh, well, maybe that's not what it's for. Maybe it's if it does become jammed, this allows you to open it up and kind of poke your finger in there or something to try to get the ball out. Although that's never happened before. But what I didn't understand, what kind of bothered me is I wasn't understanding why it would jam at all. Because it wasn't obvious to me when I was feeding into that this would cause the ball to go in a certain way or not. But when I take it apart, I see that there's this piece in here, and then also on here there's a matching piece. And I think what happens is the ball comes up here, and this little nub right here and this little nub right here hold the ball in place for this piece to come back, and then it goes in there like that. Basically, the reason these are spring-loaded is so that to allow this piece to come back and just kind of take the ball inside. That's it. I've taken it apart and I figured out what everything does. I don't think I can put it back together again. I'm trying to figure out right now if I want to even try. It said that I was supposed to mention whether I was able to put it back together, and I'm gonna go ahead and, can you see me? I'm gonna go ahead and go out on a limb and say I can't put it back together, but part of me wants to try.
So what did you learn?
I learned what all the pieces do. I don't think I could rebuild it without looking at it. I don't think I understand it that well, but I think I understand it well enough to do a force flow diagram. I think it would be a rather complicated force flow diagram. I am going to give it a try. The difficulty in making a force flow diagram is I don't have a name for all the pieces. Like, this is the firing pin, that's the thingy that holds the other thingy while I'm waiting for the other thingy to trigger the other thingy. So it would be difficult for me to make a force flow diagram because I don't know what all these pieces are called. So I guess you can make simplified force flow diagrams, and I'm going to try to, I'm going to make an attempt at it anyways. So I'm going to have to name all of these pieces. And
Can you just name them for what they do?
but it would be this thing holds the other thingy while it's waiting for the other thingy to move it out of the way. So yeah, I think that's going to be some work to make the force flow diagram, because I'm going to have to name all of these pieces.
What do you wish you'd known before you started that you know now? Or just that you wish you knew before you started?
Well, there was the one thing with the screws. I wish I'd known there was different size screws, but at the time I had this fantasy that I was going to put it all back together. But now that I have it disassembled, like putting it together seems like a very daunting task. And I think I'll go ahead and give it a whirl. Maybe you can just film it on silent, and then I can do like a fast video. You know, when they like fast forward. With that, I think we're done.
Did you do anything wrong?
Did I do anything wrong? I should have not taken the screws apart, or taken each piece apart one at a time, so I knew which screw goes back in which hole. But I have that I can't even, the rest of this I could put together by trying to like go back to places in the film and remembering what it looks like. But with that piece I can't get that back. So one of the screws, I might put the wrong screw in the wrong hole.
So if you did this again, what would you do differently?
That's about it. I would only unscrew one screw at a time. Once I get lost in the process, I wasn't doing a good job of methodically going through the functions, materials, and methods. I think without too much effort, I could, theoretically, it would take a long time, but I could make my own gun if I had CAD drawing tools, and I think I could repeat this design. I realized something that this piece that I said before was on top, or the part that made the ball, I thought it was on the bottom, and that would cause the ball to have a top spin, which would curve it down, which didn't quite make sense to me, and I had it exactly backwards. This piece right here is on the top, which means the ball is going to spin like this, and when the ball spins like this, the laminar flow will be on the top, and that will cause the air to go down, which will force the ball to go up. That will cause the ball, if anything, to curve up. So, anyways, that's pretty interesting. I also discovered putting it together, I think I figured out the right way to disassemble it as I'm figuring out how to assemble it, because I was able to put this piece together by putting these screws in first, and so anyways, so far it's going together in a more elegant way than I took it apart. So, before, we didn't know where the big screw had come from, and I'm gonna go ahead and guess, since all of the pieces that were for the receiver assembly, which is what I'm going to call this area right now. Maybe it's a trigger assembly, I'm not sure. But anyway, since they were all small, and this is part of that, I'm going to put the small one in there, and I'm going to put the big one in there. And let's see what happens. Well, that's not good. I'm not sure why, whatever state it was in, kind of it got out of when I released all the tension by taking the cover off. So I'm not sure how it failed, but I'm going to attempt to put it together one more time. I mean, the pieces all seem lined up to me. I did notice down here that one of the screws didn't seem to have properly seated itself, so maybe that was part of the problem. So one thing I just noticed is that I think this does have another function, and it's to stabilize the receiver assembly to the rest of the weapon. I noticed that when it's not there, there's a little bit of play. Not much, but it's probably not a completely necessary function, but it was providing that stability at this end here. Alright, gonna try it again. Yeah, so I'm missing something in the assembly because this is not supposed to just ride forward like that. So I figured out when I'm reassembling it, this piece right here isn't behaving the way it used to. So there's some linking up of assemblies in here that I didn't do correctly. So I'm gonna give it one more go. So one thing I just noticed is before I didn't understand the purpose of this, but now that I play with it a little bit and it's kind of put back together, I see that the decaulking actually, I thought it just wiggled this, but it also pushes on this. So if there was a ball jammed in there, this would directly kind of fiddle with the ball. So interesting. So now I understand the purpose of that piece right there. Well, I give up. So this concludes the teardown. I hope you enjoyed it.